Welcome dear children. In this session we are going to learn Standard 8 Unit 10 Changes Around Us. We all have heard the saying, change is the only constant. Children, have you ever sincerely meditated upon this question? If you did, you will realize that in fact change is all around us. Whether we are conscious about it or not, we keep witnessing it on a daily basis. Whether it is day changing to night or water turning to ice, fresh flowers in the morning and drooping by evening, etc. These are the examples for changes that we see around us. Children, some changes take a shorter while to happen, while others take longer. Let us know more about it. First, what is a change, children? How it can be defined? Change can be defined as an act by which a thing forms or becomes different than its previous self. For instance, when ice melts, it changes into water. Therefore, it turns its form from solid state to liquid state. Children, there are several types of changes that takes place around us, such as slow changes, fast changes, periodic changes, non-periodic changes, reversible and non-reversible changes. Let me explain one by one. Listen. First, slow changes. It is a kind of change that will happen over a period of time slowly. For instance, a boy becoming a man is an example of this, as it happens over the years. Because a boy cannot turn into a man within a few days. It takes many years to happen. So this change will be a slow change. Next, fast changes. As the name suggests, fast changes occur sooner. The changes that takes place in short period of time are called fast changes. These changes happen very quickly and very fast, such as bursting of crackers, burning of matchstick, batter turning into pudding. If you see, it will take hardly a few minutes for a liquid batter to turn into a pudding. Next is the periodic changes. In periodic changes, the changes that keep happening at certain intervals of time. Here, time is the biggest example of it. Every day we get 24 hours and after the periodic interval, the time on the clock is repeated again. Another example of this can be that of weather. They keep coming after a certain interval of time. Next is the non-periodic changes. The changes that occur once are non-periodic changes. Unlike periodic changes that have a set of time coming and going, here non-periodic changes have no such set of time. For instance, a random rainy day during summers may be considered as a non-periodic change. It changes the weather for a day, but it is not a periodic change. Next is the reversible change. Those changes which may be reversed are reversible changes. This means we can get the matter back after change. For example, change of water into vapor. We can get water back from the vapor again. Thus, a change of water into vapor is a reversible change. Next is irreversible changes. A change that becomes permanent in nature is an irreversible change. In this, we cannot get the matter back after the change. For example, when we burn paper, it turns to ash and cannot be turned back to paper again. Therefore, irreversible change is a permanent change. Next is natural changes. In this change, man has no control over the natural changes. Thus, change occur due to nature is called natural changes. For example, rising of sun, setting of sun, change of cloud into rain, etc. are the examples of natural changes. So these are the several types of changes that we see in and around us. I hope children, now you would have got some idea about what are the changes that happen around us. Now let me go depth into the lesson. Students, have you ever visited Qutub Minar in Delhi? Some may would have visited and some might would not have seen. Look at the picture, students. In Qutub Minar, you can see a rust resistant iron pillar. What is this rust resistant iron pillar? Listen children, rust resistance means it refers to how well a substance, especially a metal, can withstand oxidation or some other chemical reactions. How oxidation process can form rusting? It can be explained as the iron, it can be any metal, when it reacts with water and oxygen, it forms hydrated iron 3 oxide, which we can see as a rust. But Qutub Minar has not rusted for more than 1500 years due to the presence of rust resistant pillar. Students, but not all the things are unchanged like this. Many things we see in our daily life are changing. You could have noticed the milk turning into curd. How it is happening? Listen. The milk is converted into curd by the process of fermentation. The curd is formed due to the chemical reaction between lactic acid. It is done by lactobacillus bacteria. So children, we see number of changes around us. Some of them are physical changes and some of them are chemical changes. So we should know what is meant by physical and chemical changes. Physical changes means properties such as shape, size, color and state of a substance are called its physical properties. A change in which a substance undergoes a change in its physical properties and new substance is formed. It is called as physical changes. Most of the physical changes are reversible. For example, changes like folding and unfolding a paper, drying wet cloths, bending of iron rod, vaporization of water, condensation of water are some of the examples for physical changes. Next, chemical changes occur when a substance combines with another to form a new substance. Here, the matter change and a new substance is formed after the change. So, chemical changes are irreversible. This means we cannot get matter back after the chemical change. So, some of the examples for chemical changes are burning of paper, digestion of food which takes place in our body, turning of milk into curd and decaying of vegetables. These are some of the examples for chemical changes. So, children, in this lesson you will study only about chemical changes, factors determining chemical changes and the effects of chemical changes in detail. First is chemical changes. Chemical change I have already explained. A chemical change is a permanent and irreversible change which produces a new substance. What is irreversible changes? That also I explained, children. A change is called irreversible if it cannot be changed back again. In an irreversible change, new materials are always formed. For example, you heat a raw egg to cook it. The cooked egg cannot be changed to a raw egg again. Similarly, when you burn wood, you get ash and smoke. You cannot change the ash and smoke back to wood again. So, these are the examples for chemical changes. So, chemical changes are otherwise called as chemical reactions because one or more substances can be called as reactants that undergo a chemical reaction to form one or more new substances that will be called as products. Next, we will see the factors determining the chemical changes. Students, chemical changes will not occur at all the conditions. For a chemical change to take place, certain specific conditions are required. What are the changes required? Listen, chemical changes can take place based on the following conditions. First is contact in physical states. Second, solution of reactants. Third, electricity. Fourth, heat. Fifth, light. And the last is the catalyst. First is the contact in physical changes. Children, we experience many events in our daily life like burning of matchstick on rubbing and iron materials turning into reddish brown. Why and how these changes will happen? These changes are due to chemical reactions by contact in physical states. So, combination of reactants in their naturally occurring states such as solids, liquids and gases is referred to as contact in physical states. For example, when dry wood comes into contact with fire, it burns with the help of oxygen to form carbon dioxide, which is given out as smoke. When a matchstick is rubbed on the sides of a matchbox, a chemical reaction takes place to form heat, light and smoke. Students, I hope you all would have seen matchstick and matchbox. The head of the matchstick contains a chemical compound, potassium chlorate and antimony trisulfide, whereas the sides of the matchbox contains red phosphorus. It is also a type of chemical compound. When quicklime comes into contact with water, it forms slaked lime. The other name for quicklime is calcium oxide and slaked lime is calcium hydroxide. From the above examples, we can conclude that certain chemical reactions can take place only when the reactants are brought in contact with each other in their physical states. Second factor is the solution of reactants. Children, when milk is mixed with coffee decoction, the color of the milk and the decoction changes due to chemical reaction. Similarly, when we mix two substances, that is reactants, in solution form, a chemical reaction takes place between them to form new substances, that is products will be formed. For example, take a small amount of solid silver nitrate and sodium chloride in a test tube. No changes will be observed because both the reactants silver nitrate and sodium chloride are in the solid state. So children, if both the reactants are in the solid state, no reaction will take place. But if we dissolve the same reactants in water in a separate test tubes and mix both the solutions, we can observe silver nitrate solution reacts with sodium chloride solution to form a white precipitate of silver chloride and sodium nitrate solution. The chemical equation for this reaction is AgNO3 will be silver nitrate when it reacts with sodium chloride NaCl. What are the products formed will be? First is silver chloride AgCl will be formed, and another product formed will be sodium nitrate. The molecular formula for sodium nitrate is NaNO3. So AgNO3 silver nitrate, when it combines with sodium chloride NaCl, AgCl silver chloride and sodium nitrate NaNO3 will be formed. So from the above reaction, we infer that some chemical reactions proceed only in solution form, not in the solid form. Next factor is electricity. What is electricity? Electricity is a form of energy that can be carried by wires and is used for heating and lighting and to provide power for machines. So, electricity is essential for our living. In our daily life, we use electricity for cooking, lighting, grinding, watching television, etc. Children, do you know that electricity can also be used to carry out chemical reactions? Listen, it will be very interesting. Many chemical reactions which take place with the help of electricity are industrially very important. As you know, water is made up of hydrogen and oxygen molecules. So when electricity is passed through water which contains small amounts of sulfuric acid, hydrogen and oxygen gases are liberated. Similarly, brine is a solution of sodium chloride and water. The process of electrolysis involves using an electric current to bring about a change and new chemicals will be formed. The electrolysis of brine is a large scale process used to manufacture chlorine and sodium chloride salt. Two other useful chemicals are also obtained during the process. One is sodium hydroxide and another is hydrogen. It is important that the chlorine and sodium hydroxide produced in the process are separated. They get reacted when they come into contact with each other. So, the final product obtained from the electrolysis of brine are chlorine, sodium hydroxide and hydrogen. The chemical equation for this process is when 2 NaCl reacts with 2 molecules of water, chlorine, hydrogen gas and 2 moles of sodium hydroxide will be produced. Here, chlorine is used as a disinfectant and purifier and also in the manufacture of hydrochloric acid and making plastics. Sodium hydroxide is used for processing food products, removing pollutants from water and in the manufacture of paper. Hydrogen is used in the manufacture of hydrochloric acid and potential as a pollution-free fuel. Thus, we can conclude that some chemical reactions proceed only by the passage of electricity. Hence, such reactions are called as electrochemical reactions or electrolysis. The term electrolysis was introduced by Michael Faraday in the 19th century. The word electrolysis is a combination of two terms, electron and lysis. Electron is related to electricity and lysis means decomposition. So, electrolysis means it is a process of using an electric current to cause chemical change in a liquid. Next factor is heat. Food is important for our survival and also for the survival of many other living beings. Children, have you ever closely watched your mother cooking food? She boils rice, cooks vegetables and prepares gravy by heating them over stove. When enough heat is given, some chemical reactions take place to convert the raw food, that is the uncooked food, items into cooked ones. The chemical reactions accompanying evolution of heat are called exothermic reactions, whereas chemical reactions which involve absorption of heat are called endothermic reactions. Exothermic reactions generally takes place in different day-to-day real life activities. Let's see some of the examples for exothermic reactions. Students, every time you don't require a chemistry lab for experiments. Sometimes things present around you are also useful for understanding the nature of reactions. The best example for this is the detergent powder. Simply dissolving laundry detergent in a bit of water generates heat. So this is a process of exothermic reaction. One simple example for an exothermic reaction is combustion, such as lighting of candle. An initial input of energy causes oxygen and wax react to produce carbon dioxide, water and heat. The best example for endothermic process is ice cubes, because it absorbs heat energy from their surroundings and melt to form liquid water. Another best example is when we put sugar in a bowl and burn it by a flame, it starts generating heat. It releases a huge amount of energy which makes it an endothermic reaction. Children, you can also learn more about endothermic reaction by conducting in the laboratory. For example, take a small amount of lead nitrate in a test tube and heat it gently over a flame. What you can observe? You will hear a cracking sound and there will be an evolution of reddish brown colored gas, that is nitrogen dioxide gas will be produced. Similarly, in industries, limestone rocks are heated to get quicklime, that is calcium oxide. The other name for quicklime is calcium oxide. Hence, some chemical reactions can be achieved by the supply of heat only. These reactions are called thermochemical reactions or thermolysis. Students, limestone is the raw material for quicklime, slaked lime and cement. What is raw material? Raw material means it is the basic material from which a new product can be formed. So from limestone we can synthesize quicklime, slaked lime and cement. Next is light. Students, what will happen if there is no sunlight? All the living organisms will be affected and there will be no food for us to survive, isn't it? Sunlight is very important not only for us but also for plants. As you know, photosynthesis, photo means light and synthesis means production. So it is a process in which light energy from the sun is used by the plants to prepare starch from carbon dioxide and water. The sunlight induces the chemical reaction between carbon dioxide and water, which finally ends up in the production of starch. Thus, chemical reactions induced by light are called as photochemical reactions. Some other examples for photochemical reactions are first in humans. There will be a formation of vitamin D by exposure to sunlight. Next is bioluminescence. Bioluminescence means it is the production and emission of light by a living organism. Example, in fireflies, an enzyme in the abdomen catalyzes a reaction that produces light. Next is photodegradation of many substances. Photodegradation means a substance or object will be decomposed or gets destroyed easily by the action of light, especially sunlight. Example, polyvinyl chloride. Medicine bottles are often made with darkened glass to prevent the drugs from photodegradation. Next is photodynamic therapy. It is a treatment that uses special drugs, sometimes called photosensitizing agents, along with the light to kill cancer cells. These drugs only work after they have been activated or turned on by certain kinds of light. Photodynamic therapy is used to treat variety of conditions like pancreatic cancer, bile duct cancer, esophageal cancer and lung cancer. The last factor is the catalyst. Children, sometimes you are advised by the elders to drink a small amount of Oma water after a heavy meal. Do you know why? This is because Oma water makes digestion faster. Likewise, in industries, some chemical substances are used to speed up chemical reactions. These substances are called as catalysts. For example, metallic iron is used as a catalyst in the manufacture of ammonia using Haber's process. This ammonia is the basic material for the production of urea, which is an important fertilizer in the field of agriculture. It is widely manufactured by Haber process from nitrogen and hydrogen. The Haber process takes nitrogen gas from air and combines it with molecular hydrogen gas to form ammonia gas. Hence, nitrogen and hydrogen are taken in the ratio of 1:3 by volume. Next, in Vanaspati ghee for dalda preparation, finely divided nickel is used as a catalyst. Thus, speed of certain reactions is influenced by the catalyst, and such reactions are called catalytic reactions. Next, enzymes and yeast are called as biocatalyst. Biocatalyst means it is the use of natural substances to speed up, that is, catalyze the chemical reactions. For example, enzyme proteases helps to break down the proteins in human body. Similarly, enzyme amylases helps to break down the starch into simple sugars in our body. Since these catalysts are present naturally in our body and undergoes a chemical reactions faster, that's why it is called as biocatalyst. I hope you all would have understood. Thanks for watching, children.